how to get perfect 3D prints. So I've been printing now for over 15 years. And technology's changed quite a lot, but there's a lot of things that I've learned over time to just make sure that you have really, really good prints, basically. And they range from materials to slicing, calibration, and a whole bunch of different things that you can do to make your prints better and better. And what I've seen over the years is this technology has gotten a lot better. The software's gotten a lot better, and that kind of does two things. It kind of means that people that are using this software don't have to know as much to use it. And that's a good thing and a bad thing, because it means that you can hit the ground running and you can do all these things and you don't have to be a mechanical engineer to use them. And like, trust me, like 10 or so years ago, you had to be quite mechanically minded to use these machines because they'd always break down. But now you can use them without knowing some of these things, or a lot of these things. Like, you don't have to do a temperature calibration. The flow rate is already set, and there's a dynamic calibration that already happens. Like, retraction's already set if you have printing profiles from your filament. So there's all these things that kind of get taken care of, and that's an attempt to make things easier, say, from the manufacturer, but it's not necessarily going to help you long term. So basically today, this is going to be a full guide on the things that I do to help create the most reliable prints and the highest quality prints. So quick question, because I can monologue forever, especially about 3D printing. Quick question. Has anyone here ever printed a temperature tower? You can chuck it in the chat if you...
Yes, I have.
You get a yes there, or did I? No, I got a thumbs down from Liz. That's okay. So a temperature tower, let me see if I can share my screen, actually. Does anyone even know what a temperature tower is? Because I'll share my screen so you can see what I'm seeing. Entire screen, window 2. So here we're in Maker World, and if I just type in temperature tower, you'll see that I've got all these different examples. And you can see here on this one that the color here of the slice preview changes. And in the slicer there, you can actually see, you can insert commands at different heights to change the temperature. So basically, you're printing this tower with different temperatures at the different increments. And it's kind of a funky shape. Like, it has these overhangs. So it's got two different types of, angles of overhangs. It's got like a 45 degree and then a more extreme, like, I think it's usually like a 70 degree or something like that. And then you've got these little cones in the middle. So I click on this one, you might be able to see a bit better. But you've got these little cones in the middle, and that's like to understand like retraction. You've got bridging, because you've got this like whole kind of gap here that the printer has to bridge. And then you've even got top surfaces where the overhangs are. They're flat surfaces. So these are basically testing common features in your potential design that you're printing. Like, this person, whoever designed this temperature tower, they don't know what you're printing, so they're just giving you like a lot of different features to like test. It's kind of like a torture test. So why did I bring this up first? Well, 3D printing and the style of printing that we all use here is 100% linked to temperature. Like, you take a solid, you heat it up, and then you re-solidify it. Temperature is the key driving force here. Like, it's the number one thing that you basically, governs like how the plastic behaves. So if you only want to calibrate just one thing and don't take away anything else from this tutorial, this is the number one thing that you should do. Okay, So you print this, and basically that will give you um, a different, like it'll go from say 225 degrees to 190 degrees. Say if you're printing PLA, that'll work fine. If you're printing other materials, you might want to like change it. But you can see here they've got PLA, ABS, and PETG. It's like kind of suitable for those. Now it's going to probably look quite bad, or hopefully it looks kind of quite bad at some of the extremes or one of the extremes, because you're trying to find the right temperature. So you might be asking, what is the right temperature? How do I actually know when I print this thing what the best temperature is to use? And the answer is it kind of actually depends on your application. Like, do overhangs matter more than stringing, like with the retractions, or do top surfaces matter more? So for my business, we print a lot of different parts, but something that we do a lot of is printing parts that are like plaques. So basically, if you can see my screen here, we've got like this plaque here, and it's got like the customer's like name and like it's an Easter plaque basically. So top surfaces matter so much to me because I'm printing parts that have like big top surfaces. So you kind of have to take what matters to you most. Like, is it the surface finish or the shine? Is it the retraction? So you kind of just look at the best kind of region depending on what you want, and then you go from there. So that's how you do it. And once you have that temperature selected, you can really easily change your profile. And you can actually even compare it to what you were using previously. Like, it might not be that far away, but here's the thing, like, why not do it? Like, you print this once, like it'll cost you like less than $1 of material or something like that. And then like forever and always, you'll just have a slightly more optimal like temperature, just slightly more better results. And it's all these 1%ers that add up to a big difference in the long run. So that is the first calibration, and probably the most important calibration. So once you get that temperature, you go to your profile, you go edit, and then you just scroll down to, or you can click advanced here if you, oh no, I've got developer mode on. So you can scroll down to here, and you change your, oh no, it's not that one, it's this one here. So print temperature, and then you change the one for other layers, depending on what it is like that actually gave you that temperature. All right, any questions on that? Awesome. Yeah, let me know. Just throw them in the chat. I've got the chat open here so I can see you guys now. Oh, yep, Dennis, you printed one. Awesome, mate. No, that's great. So yes, you can just use so the manufacturer will often provide settings. So if you use Bamboo lab material, you will just go to this drop down and find the material here. If you use, say, Filiform, you just go to the drop down, and like we've got all these settings, so you just like download it and like you put them in here. If the manufacturer doesn't have it, you'll kind of have to make them yourself, and that's why these calibrations are like a lot more effective when you're kind of going off that, like something where you're not given the profiles. I think you should always have, like, the manufacturer should give you the profiles. Like, if they're serious about 3D printing, that's what they're making the filament for, they should probably just give you the settings. Like, it doesn't make sense to me that some don't. But yeah, so yeah, find your settings and then optimize it from there. Okay, so that's the temperature tower. The next thing that you need to do is the flow rate calibration. So to use the analogy, we figured out the optimal temperature to print the material, but how much do we push out? Now, mathematically, we calculate the perfect amount that needs to come out of the nozzle to make our part perfectly. That's like theoretical, right? What happens in reality is that we need to adjust our exact flow rate slightly, because sometimes we get slight under or over extrusion. So we just need to basically like make a really tiny adjustment, and that's with the flow rate. So if we go to calibration, it's not flow dynamics, it's flow rate. You'll see that you have A few examples here with bamboo slicer. Now you can do this on other slicers. There's probably an equivalent version of these. I'll show you what you need to do though to do this manually yourself. But bamboo slicer does this automatically. There's an automatic flow rate calibration here, and if my internet wasn't failing right now, it would connect to my printers, and then I would have an auto calibrate button here, which basically it'll do two things. It'll print a series of these cubes. So let me show you what that looks like. So we've got actually a slicing course here, and we got a flow rate calibration one. So it prints a series of these cubes here, and they all have different flow rates. So it'll do two passes. It'll like calculate, like say, hey, like these cubes look perfect, or rectangles or whatever. They look great. So you'll basically tell it, hey, that cube there, that was the best one, and then it'll do another go and print more of these rectangles that are closer to that one that you selected, and then basically it'll just calculate the flow rate there. So if I kind of show you this, like you get your print, it's really easy. And then once you put in, you say, hey, the -1 for me was the best one. And then I put it in here, and look, it gave me a flow ratio of 0.97, blah, blah, blah. Okay. 0.97 basically is saying that from that ideal flow ratio, which is like 100% or just 1, we have to reduce it just by 3% or just about 3%. That's what the 0.97 is. Instead of 1, it's going to 0.97. So where does that actually show up in here? How do we actually make that change? We go to edit again from our project filaments. And it's at the top actually. It's like it's called flow ratio. So I would put this to 0.97. Now I like my top layers to be like really smooth, so I actually bump this up to make sure that there's no gaps. But I don't get surface roughness at 1 at a ratio of 1. But if I was optimizing with what I was just showing you in the calibration tab, that's what I would do. So this gives you the right amount of material to come out of the nozzle. Does that make sense? If you look at an over extruded part, what happens is that you have too much material, and therefore those layers start to push together and bunch up. So you get raised kind of features, like you get features that are protruding and pushing out from where they're meant to be. This cube will also be slightly bigger than your dimension, like whatever the cube was meant to be. If this was meant to be 2 centimeters, it might be slightly bigger, only a very small fraction. So geometrically, also you have slight increase in the size of your part, because all of the walls will be slightly bulged out. And then with under extrusion, you don't get enough. So typically, you might see gaps in the top surfaces. You might see that the walls, like the part's not as strong in general, because, and this is a really important one. Like if you're making strong parts, you don't know what the so what am I trying to say? So if you're making strong parts, how does 3D printing actually produce strength? It builds a part layer by layer, and then inside of a layer, say when it does 2 walls, it's printing one wall next to the other. And what actually bonds those walls together? Again, it's the most important thing. We're talking about a thermoplastic. You heat it up, right? Now, our printers nowadays are really fast, and they have really good cooling. So those walls don't always get the time and the heat that they need to really properly fuse together. It's a plastic. It needs to actually fuse together. So if you print parts really slow, you'll get stronger parts, guaranteed, right? That's just like I've done tests with it, but you don't even have to do tests to do that, because that is just physics, right? you get bonding because of the heat and the time. And when you under extrude, that pressure against the two lines of plastic, say you've got two walls, is just less. And that's why you get weaker parts. So if you want stronger parts, if anything, try and over extrude it. Obviously, you're going for perfect or slightly over extruded just to make sure. Okay. So that is flow rate. Now, I didn't want to touch on this because it's a bit more advanced, but I guess I could just like quickly bring it up. Does anyone know what flow dynamics is compared to flow rate? Because flow dynamics is a different calibration tab here. And you can see that it like the before and after, like it looks quite different to the flow rate calibration. Flow dynamics is talking about how a material has a slight delay when you try and like push the filament and it melts, because physically it needs time to actually absorb the heat and then melt and creates pressure and then it flows, right? There's a really, really small delay that happens when you decide to extrude material. Flow dynamics tries to account for that. And when you actually do a print, let's see here if I can. So I hit print plate, sorry, my printers are connected to Bamboo Farm Manager, so I can't do it this way. But you'll typically see there's an option there for flow dynamics to turn on or off. And what actually happens is that flow dynamics will automatically get done for a lot of these newer machines. So, for example, I've got Bamboo Lab A1s. They automatically purge material at the start of every print to check what's the delay between when I push and when the material comes out. There's like a little sensor in there. And what I found is that auto calibration is really good. So I actually don't calibrate my flow dynamics at all. If you have issues with it, what you'll typically see is that when the printer or the nozzle changes direction, or when it starts and stops somewhere, you might have little gaps between the walls and the infill. That's what this is showing. And then typically what you do is you print, yeah, exactly. You print this, where is it? Let me refresh the page. The thumbnail actually had it. You print this kind of calibration in that menu on the slicing software, and it'll do these starting and stops, and it'll figure out, hey, these are the actual delays that you need. The actual value here, I only learned this yesterday. I didn't know what the value was. I knew it was about some sort of delay, but it's actually in seconds. In seconds, how long it takes to actually, when you decide to extrude to when material comes out. So you can leave this on automatic, but if you're having problems, then this is where you go to actually fix that, okay? So if you're having those little gaps between like walls, or when the printer starts and stops and there's little gaps, then you might want to look at dynamic flow calibration. Most likely, you don't need to do this, but because it's automatically being done. But if you start to see that you're having issues, maybe you've got like moisture in your filament, or maybe the temperature when you started the print and when it was going, like fluctuated too much in the print environment. And that's when you can start to have issues, because the actual temperature changes, therefore the delay of when you push filament and when filament comes out will change too. So yeah, without giving you an engineering degree, that's pretty much what the dynamic flow calibration is. Really, it's a thermodynamics problem, but it's quite incredible that this happens automatically before every print. So yeah, it's important for you to do this with your printer, your nozzle, your material, your ambient conditions, like all of those things, to make sure that you get the best print. Okay, so that is dynamic flow rate. The next one that I wanted to talk about is first layer test print. So say I go to make a lab. What's it called? Oh my goodness. Make a world. Thank you. First layer calibration. Say you've done everything the temperature tower, the flow rate. But sometimes you just get like bad bad first layer adhesion. And you've cleaned your bed and you've say even used an adhesive spray or something like that, and you're still having issues, then maybe yes, it's a temperature thing. Maybe your filament has moisture in it, right? As well. But if you've ruled out a lot of those things, just print a really big cube that is one layer or maybe two layers tall. It's really easy to do that. You could just like search these ones up, download and open, and it'll just like open up. Or you could just insert a cube and then just like rescale it. So see here how it's 0.2 millimeters on top. So that's how I would do it. And this can be used to calibrate your first layer, because if you change your nozzle temperature, or say a big one for the layer, say you were still having issues and you did all the other things, the filament's new, the bed's clean, adhesive, blah, 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 then it might be a temperature thing, or it might be a speed thing, print speed thing. So you know how we're talking about thermoplastics, we heat them up and then they cool down. The temperature is like the key driver here. That is true for creating the part, but also for the part sticking to the bed. Usually, most of you probably have like a textured PEI plate. That's a type of plastic. And the texture helps the material grip into it. Even if it's smooth, there's still texture in it, and the heat helps the part stick, right? You need temperature and time to create that stick. So if you want more stick, you either increase the temperature or you decrease the speed. So you increase the amount of time that the nozzle spends on each, at each spot. Like it takes longer to print that first layer, and therefore it'll stick better because it's spending more time, hotter against the actual print bed. So Patrick at 3D Printer Gear showed me some of the first layer calibration tests that he's done, and that he uses this to check his temperatures, and even when they do have new filaments. So like when we have the Filiform Naked range, we did it with this and tested the settings, the printer profile settings, and his first layers looked like a sheet of paper. Like they looked exactly like a sheet of paper. Like it was so uniform that it's ridiculous. So, and we did that on A1s. We've done that on P2Ss. Like we've done that on. It doesn't matter like what printer you have, right? Like you can do that on all these different printers. So do a first layer calibration. Now, if you still have issues, this is like kind of like a side note. There are screws that what is it? Screws in heated block. So there are screws. I'll try and find it. So the way that the printers work is they'll touch each of the points, right? They'll do mesh bed leveling, and there's a sensor in the nozzle. All good, Adrian. See you later. There are sensors in the nozzle that basically will detect the position when it touches each of the corners in the bed. But those sensors and the whole nozzle itself is actually mounted to your printer. And sometimes those screws get loose. Literally, you just like need to tighten them, and then it's good to go. So if you're having first layer issues and you've tried all this, you figure out your temperatures, maybe you've reduced the print speed slightly, you make sure it's all clean, use an adhesive spray, then it could just be something that is just the actual tool head. Tool head, the screws just coming loose. I won't be able to find it now, but yeah, that's it there. Okay. Next, say I print a lot of pieces. A lot of pieces. What happens when you print over and your printer has to travel back and forth is that it has to lift the material and then re-push it back down into the nozzle. that's called a retraction. So these retractions are automatically done in the printing software, but basically you need to look at this like in a practical way, right? If you're printing one part that has 2 or 3 retractions per layer, that's barely anything. Um, the flow of your material is basically you're almost always extruding in that case, right? But if you're printing something, let's say like this bit here, right? It's got a tiny little extrusion and then a retraction, then a tiny little extrusion, then a retraction. So most of the time in this print, it's actually retracting. So the actual pressure is not very consistent at all. Like it's always taking off the pressure and then re-adding it, taking off the pressure and re-adding it. And I'm talking about the pressure of the actual filament into the nozzle, right? And what you'll find is this, right? If you have a lot of retractions like this, and especially if you have materials that are more challenging, so like they require higher nozzle temperatures, or maybe they even require heated chambers, so usually higher performing materials, then you're going to be absolutely fine sometimes to print one of those parts. But if you're in a business setting or you want to print a lot of them, then that's when you can start to run into issues, because it's like an accumulated effect. You just keep taking off this pressure and it has to keep re-adding it. And if there's a little kind of error, like it under extrudes slightly once, and then the next time it retracts, it under extrudes slightly, like it'll build up basically. So we've had clients that have come to us and gone, I love the machines, they're great, and I've printed whatever this product on it, and it's fantastic, okay, but I have a problem. I can only print 1 or 2 of them, but if I try and fill up a bed, it just doesn't work. That's usually a retraction issue. So yes, you need to go through the temperature tower calibration, the flow rate calibration. You need to go through the dynamic flow calibration. If you've done all of that and you're still having issues, then retraction's the next thing to look at. And the way that we do that is there's 2 tests that I use. So this one is the advanced version. This tests different distances of retraction and different speeds. So how fast do you pull the filament back? And how far do you pull it back to reduce the pressure during a retraction? That's what this one does. It does a really comprehensive, like it changes it like programmatically, or it changes it step by step. Okay, so you can basically get a whole picture of how those retraction settings change. And then with this one, this is the simple one. Basically, you can change the speed of retraction and the distance manually in your filament settings. So you just go here, you go edit, and then I always have to look it up because I can't remember I barely ever touch this one. But it's here. So settings override. So go to retraction speed. Oh, that's right. Yeah. Your main retraction settings are actually in the printer settings now. You have to like edit the actual printer settings. So you have to override them in your filament settings when you change it. So you might go, I'm going to override retraction speed, and the default is 30. So I might try 50 and make it faster. Like it pulls the filament back faster. So hopefully I avoid stringing then. So you might do something like that, redo a print and see like, do I get stringing or not? Yeah. Yeah, super, super important when you're building a business, especially, and you want to like fill up your print bed and make sure that you're getting the most out of your machine. For PLA, maybe not so much. You're not going to have as many issues here, but I mean, maybe you do have some stringing. But yeah, usually if you do dial in temperature, you'll be fine. It's more for the advanced materials that you'll need to do something like this. All right, any questions on that one? All right, cool. Our next one we got is, so I want to show you guys this. I don't know if you guys have done this since you set up your machine, but every time you lubricate or change something in your machine, even if you move it, you want to just quickly do this, like, I think it's like a 10-minute calibration. So it'll do bed leveling, noise cancellation, any type of like resonance stuff, and it depends what machine you have. Like if you've got an X1, it'll do a lot more checks. If I scroll, sorry, my mouse is a bit buggy. If I scroll down here, this is the A1 series. Again, motor noise cancellation, vibration compensation, and then auto bed leveling. Does like a really, um, really quick, not a quick, sorry, it actually takes a bit of time. It's almost half an hour, um, like calibration. So this is really important because any changes to the machine will change the way that the motors um, vibrate. So you have to like do that vibration compensation, and then the noise cancellation. Noise is noise is made by vibration as well. So this is kind of like, yeah, I don't know the exact differences between these two. They're quite similar. Um, because noise is caused by vibration. So you just want to avoid, when you make a change, any kind of like extra movement, because vibration and noise is movement, and you're laying down molten plastic. Any movement is going to be felt by it. So, yeah, that's what we need to do there when we make any changes. And this one you can just go to settings, maintenance, and just go run the calibration. Literally hit start, and then you're done. So if you move it into another room or another desk, or you do some maintenance on it, just click that. Really really easy to do. Cool. Has anyone ever done that one apart from the setup? If you got a lot of machines, even on your bamboo like farm management systems or farm management systems, you can make them all do this like simultaneously, and then they'll all like sit there and hum and vibrate. Yeah, it's pretty cool. Like what the checks are. Yeah, it reduces the noise. Yeah, absolutely, and and it's really really easy to do. So how you get to the menu, Natalie, is you go to typically it'll be under settings, maintenance. So it depends on your printer. So this is the P1 series, calibration, and then it does a calibration. So the X1, it's under utilities, calibrate. So calibrate or maintenance, somewhere there. Yeah, no worries. Okay. The next thing, super important. I saw this post on Reddit, so I took the image of it here. But you need to store your filament correctly. So I need to actually do this a bit better, because so we go through like a decent amount of filament, but now that we have quite a lot of colors, we still go through a decent amount of filament, but we might have one reel open for a bit longer than we want. And especially in like colder or hotter kind of climates, you just want to make sure that you're not exposing your filament to anything that can degrade it. And what does degrade filament, right? So firstly, if it's not airtight, then it'll be exposed to moisture or humidity. So that's one thing. So you want to put it usually in an airtight container, or like those lock bags that they come with. So just save a couple of them and use them. And we can use desiccant. So just a tip on the desiccant, right? That absorbs moisture, comes in all your filament. You should all be aware of that if you've ever opened a reel of filament, right? But what you might not be aware of is desiccant absorbs and holds the moisture, and then it keeps moisture. So if it's old desiccant, it actually keeps moisture in the bag. If you reuse it over and over again, you're actually introducing moisture in a way to the filament. So you need to like rotate your desiccant. Usually it lasts a long time. It just depends how big the actual bag is. So if it's a really big bag, it might have a lot of ability to absorb a lot of moisture. But if it's a small bag, then it might absorb moisture up until a point and become, I guess, saturated, right? Like you can't fit anymore. So then, therefore, it's just like a source of moisture for your filament. So just rotate them around every so often. And the way that I would do it is when you open a new filament, you got a new desiccant, then you can swap out one of your desiccants. So you could do that as well. You can also buy desiccant. It's up to you. How serious you wanted to get here. I probably would just use the desiccant that it comes in. I wouldn't be going and spending any more money on that. Out of sunlight, that's a really important one, because that actually more specifically, it's about being out of UV light. So like a light from my just an LED light is fine, but UV is degrading. It's like harsh, like here in Australia, it's like it's like the thing that like breaks like the outer surface of anything that's outdoors. Like UV is like really harsh, especially when it's summer. So keep it out of sunlight, keep it dry, airtight, and then here's the other one. So you want neutral temperatures. So it really depends on where you're printing. I put this in here because I don't know, like maybe you're in a shed or whatever. It could get quite hot in there. In the summer, maybe quite cold in the winter. And temperature fluctuations, often with materials, like can like just throw them basically. It can do a few things. Like if it gets really hot, it could actually change the shape, like slowly over time, even if it doesn't reach the transition temperature, because you can have like long-term effects. Like it depends how long you have your filament for, but it can have long-term effects. So, just try and keep it like in like room temperature, comfortable room temperature kind of environment. We don't want to go below freezing or way too hot. All right. Oh yes, and the last one, design checks. So obviously we've gone through like all the settings now, like print temperature and flow rates and stuff like that. That's got nothing to do with what you're actually printing. So to get good prints, you have to actually understand what is required from a design for a 3D printer. And if you ever like say, you can even search this up, right? Like search up engineering jobs in Melbourne or whatever. And a lot of those jobs will say you need to understand design for manufacturing, DFAM or whatever. Design for manufacturing means you can't just be good at designing things on a computer or downloading designs on a computer, right? You have to be understanding the process in which you're making it for. So the classic example is like there are so many say things on Maker World, and I think everyone's getting better now, like because especially on Maker World, like people understand that it will be 3D printed, but there's going to be so many designs that are just really difficult to print, right? So here, like I just typed in figurines because I wanted something that was kind of detailed and intricate. Like you look at this design here, really, really cool, and probably ideal for resin printing. Now, I think they've printed this in FDM. It looks like I can see layers. So if it's resin, you can't see layers. If I have a 0.2 millimeter nozzle, I'll definitely be able to do this. But like heaps of overhangs, heaps of like small, tiny, intricate features. It looks good on the photo, like really up close, like you might have like quite a lot of defects on this, like especially if it's like a really small size, right? So it always going to come down to what you're printing and what you love making, but you just need to make sure you understand like not all parts lend themselves well to 3D printing. Like even this, like we've got a really tall part with very minimal contact at the base. Now that is what it is. Like this person wanted a samurai figurine, so they've just made it like that. If you ever have the option though to design something and optimize it for 3D printing, then this is what you do. You make sure you have a flat base that has enough contact for good bed adhesion. What does that mean? So you want to make sure that you've got a big base relative to how big your part is. So if your part is, X tall, ideally you have, X wide, amount of like contact. Because that part's going to be moving around, especially if we have a bed that's moving. If we've got a Core XY printer where only the nozzle moves, maybe we have a little bit more leeway there. We want to reduce sharp corners in the X and Y direction. So as our printer is going around and round and printing things, we don't want it to like accelerate really fast to a corner and then have to like slow down and stop. That causes vibration. The printers are good at dealing with that. It also increases print time, right? So again, like it really depends on what your outcome is. If you really want a sharp corner there, then I guess you just have to live with that, right? And if you have the option, this is why it's about having options, then yes, reduce that corner because that'll decrease your print speed, it'll decrease the wear on your machine, less vibration, so it's more reliable printing. You have less warping when you do that. So on the first layer, if you have corners, then you're going to have more warping. Like who's had warping here? Probably everyone, right? Um, One way to do that is to put like little fillets, like so smooth corners, instead of sharp corners. And the reason that you get warping there is because a corner at the tip of the corner cools down the quickest. And when you have cooling faster than other areas in materials, you have shrinkage. That's what causes warping. So even a small fillet distributes that quite a lot. That's why that's really useful. And then limit overhangs. So just as like a side thing here. So how do you actually know when you have overhangs? So say I've got this benchy. Go to paint on support. So even if you're not using supports or you just want to check what the overhangs are, you go to paint on supports and you go highlight overhang areas. And see how I'm like increasing that? And it's like showing me, literally showing me where the overhangs are. Like it's just pointing to them. So helpful when you want to like diagnose a model that you might have downloaded or even just like understand what are the angles that I've designed myself that I've put in here and like what might be problematic or maybe I need support material in a specific spot. When you get to this and you might go, oh, maybe I need support material in a certain region. Now here I won't need support material here because this is actually a really small overhang that would be fine. But I can actually go and fill this in with this fill tool on overhangs only. And you can see that now I've actually said, yep, I want support material just in that spot there. That's and then you go to tree manual, enable support material on manual mode. And then if I slice that, it'll just give me support material there. So, you want to be, in general, avoiding support material. But if you can't avoid it, then try and reduce it, as much as possible. Okay. And then, yeah, if support is needed, go tree manual. So you use manual if, for example, in this case, I wanted to make sure that I had support in a specific spot, and that's where I would use manual. If I used auto and it put it everywhere else, then that's something that I have to avoid. So if you do all these things, we're looking at like the calibration, so flow rate, temperature, the dynamic flow, even some retraction if we're having issues there. We store our filament right. We change out, we look at our design and really critically think about how can we make it optimal for 3D printing. Then we're going to set us up for the best way to have successful prints. The other thing that I'll do, and I actually want to make this for my business, I don't even think it'll take that long now because some of the AI tools that I've started really diving into is making a software that basically I install on my computer, or you guys could install on your computer, that will log when I have a print error or a problem and what the fix is. And also for maintenance, like when I lubricate things and stuff like that. So I want to do that for my business, Arinalo. And then I thought, like, well, if I'm going to make the tool, I may as well share it with you guys. So let me know if you'd be keen for something like that. I was also going to integrate a filament inventory tracking thing as well, because I remember we've had some questions about that. And obviously having an Excel document is fine, but if you can have like a nice user interface that kind of does a lot of the thinking for you, then that might be helpful as well. So anyway, I hope you guys got some good tips from this and learned something. If there's anything that I've missed, let me know. And I'll open the floor now for questions.
Hi, Tony. I have a question about support material, as in their non-binding white stuff that doesn't stick to PLA.
Yes.
And it says enable just for the interface layers,
Yep.
and I am very unsure on how to do that.
Yeah, definitely. Okay, so let's have a look at this. I'm going to share my screen again. All right, so whenever you don't know what a setting is, you can use this little search bar here. So if just in case you weren't aware of it, it's a tiny little button here. I reckon it should be a big search bar. I use that basically all the time. Even if I know where it is, I just search it because it's quicker. So you jump in here, and you said interface layers. Now it's got to do with support material. So support interface. Okay, I went there and it's showing me the speed. All right, that's not quite what I wanted. So it's probably in the support tab, interface pattern. No, not quite there. It's somewhere here. Sorry, I haven't turned this one on in a while. So are you using a different material for the support interface layers? Is that what you're saying?
Yeah, so the bamboo
Mm.
came with half a roll of white support material for PLA, which doesn't bind to PLA.
Yeah. So it's somewhere here. I just can't see it amongst all of the settings. It's under support, and you can basically change. Oh, do I need potentially two different materials selected?
Can I say this? It would be it'll be support wrap interface or scroll up.
Wrap interface.
Yeah, scroll up. Like
Oh, sorry. Yeah.
just scroll up. Yeah, so support wrap thing.
Yeah, this one here.
Yeah.
Oh, yeah, perfect. So I actually think you need two materials selected. Go yes. So basically, once I do that, and then I slice, it should actually show me if I change to the filament view. So I'll show you here, filament view. See here now, so I've got two different filaments here in my project. So that's important. You need two filaments. So I've got a brown and a yellow. Okay. Now I've left the model to be brown, and the support raft interface. Thank you, Tyson. I've selected as the second filament. So I've put PETG there because PETG actually doesn't bond to PLA, and people actually use it as an interface layer as well. But you would just use whatever filament you have. And now that I've sliced it and I've gone to filament here, you can see that instead of this whole model being brown, just at the interface, it's got that yellow bit, and that's going to separate my model from the support material. So that'll give you a way, just for you guys that might not know what this does. This means that the gap between your support and your part can be basically zero, or actually zero, and you get like a really nice smooth surface finish there. It would look very like it wouldn't even look like it had support material there. It would just look like really good. So that's when you can't avoid support material and you want that really nice finish. This is how you do it. So I hope that answers your question, Tim. That was under filament for supports.
Thank you.
You're welcome. All right. 8 minutes. Get your questions in, guys.
Hi, can you hear me?
Hi, Zach.
Hi. I don't know if this is appropriate, but I was just wondering, we've got the Bamboo Lab A1, and we just constantly get these malfunction errors with the nozzle temperature.
Yeah. What's the error?
For months now.
Yeah. What's the exact error, Zach?
Oh, I wish I could remember.
Oh.
Yeah, I wish I haven't got it. It comes up when it happens. I don't have one right in front of me, but
yeah. Does it allow you to print still?
No, we get a couple of layers in, and then it stops and has this malfunction because of the temperature.
Most likely, it sounds like like it could be the thermocouple is, so what measures the actual temperature could be malfunctioning. Has it ever had a blob of death, or like where the material, like the plastic, is kind of melted and surrounded the nozzle?
We had that once, and we cleaned that all up, and that took a long time, but it's happening now without any blobs of death.
Yeah, so I think potentially that blob of death could have got material into the thermocouple, and it just sped up, like, how quickly it wore down. Potentially, I'm not sure. Next time the error comes up, if you could take a photo of it or whatever, or write it down, and let me know, that'd be good. But yeah, it sounds like to me that it could be something like that. I can even if you have that error message, I can even send it to the tech guys, the service department, and see what they think, because they're absolute experts in diagnosing this kind of stuff.
Oh, okay. And is it a part I could buy online and replace?
Yeah. So if it is that, yes, they are replaceable. So it's like Bamboo Lab A1 thermistor. Do they call it a thermistor? Sorry. When I was building the glass printer, we bought thermocouples. They're basically the same thing. Ceramic thermistor 3-piece set. So, okay, this isn't the right one. But this, the one that you see here, is for the P1 series. So I think it's under accessories. You got to go to A1, or it could be under spare parts, A1, and then like a sensor or something like that. Or I could just search it. That'll be easier. A1 thermistor. Where is it? Thermistor A1. Surely it just comes up. No, doesn't like me. I'll after this call, I'll have a look for it. But yeah, if you could send me that error message, that'll be ideal, because then I'll have hopefully a much better answer, because I don't want to just send you to buy a part and then it's not that, right? So maybe on the 3D Printer Gear website, Mr. A1. Surely it just comes up. Or maybe it's a different part. Maybe it's like the heated block is maybe it comes all as one piece, actually, so it's not called the thermistor. I'll look it up. Sorry, obviously I don't work in the service department. Like, we sell like 30, 40 different machines. So remembering all the parts. I know that's what it probably is. I just don't know exactly where it is. So yeah, send me the error message and I'll let the guys know anyway.
Thank you so much.
No worries, Zach. All right, 4 minutes, 4-minute warning. Sal, welcome. Who have I not said hi to as well? And I've said hi to everyone. Very good. Liz in the chat said thoughts on the need for an air or HEPA filter if printing in a home office that I spend a lot of time in. I would do it, honestly, because why would I do it? So why not is probably the main thing. I'm quite risk averse, so I like to make sure that all my risks are like mitigated. So Liz, you're printing PLA, so that is the lowest risk. But if you're spending a lot of time in there, yes, you will be exposed to it, right? And exposure is kind of one of those things. Like if you take the sun as an analogy, right? You have like intensity, so how hot is it? How much UV is there? And then you have duration. So if the exposure intensity is low, because it's PLA, it's not that bad, but you're there for 8 hours, then the exposure ends up being a lot more. So yeah, the one that I've got in just here in my workshop is from Anova. Nova HEPA filter. Yep, they're really good. Never had an issue. And you got to replace certain parts and stuff. I don't know if we have them. I know that some of the printers have them inbuilt. Yeah, so yeah, activate. Yeah, so some of the printers have them inbuilt, but you've already got printers, so you probably just want an external one. Yeah, Prusa HEPA filter. Yeah, cool. Sal, I saw your hand up. Go for it. I thought I saw your hand up. Maybe not.
Sorry, I was just saying hi.
Oh, hey. Yeah, good on you. How's the design course going? I think you're muted. That's all right. Got a minute left. Anyone? Quick one before we go. All right. Thank you for hanging out with me. Is there a need to clean or replace the white PTFE tube? Yes. What material are you printing in, Natalie? PLA. Yeah. So PLA is like the least abrasive, like of all the materials, probably. So it's not going to chew through them a lot. But what's interesting, and I don't know if you've like looked this up, but wiki PT AMS light PTFE tube maintenance. this will blow your mind right now. AMS light. We got PTFE tube. I'm not going to be able to find it now. Here we go. Replace. Oh, no. Sorry, there's so many guides online. Bamboo basically say like you should be replacing this like super often, like like really, really often. I don't know how often it is. I just can't remember. I was trying to look it up just now. Because if you think about it, the filament is going through this tube and, you know, it's going to be causing resistance. Any more resistance or extra resistance is going to be affecting the flow. And especially if you have the AMS system, that resistance is bad because you get inaccuracies in your flow rate, which is really bad for printing. I would only replace it if you have an issue, personally. But technically that's not the manufacturer's recommendation. So they're saying that if you have a Bamboo Lab machine, you want to be replacing it a certain amount of time. Yeah, Natalie, if I find it, I'll send it over to you. Yeah. So the one thing to look for is the ends of the tube. No, this is probably going to give me. So bad example, but here's an end of a PTFE tube. This one's been like chewed up. You can see that, right? So filament passes through there and you can feel resistance. Then you either need to cut it or replace the tube. So that's how I would kind of like diagnose it. And if the tube gets bent, then either you can straighten it out, or if it's not creating like a clear path to the machine, then you need to replace it. Yeah. So I would go from a practical approach here. So replace it if you need to, kind of thing. All right. Very good. Thank you for hanging out with me today. If just to let you guys know, we've got courses that are being released and you know and are currently active. So in our 3D printer gear website, just go to courses. We just released an after school program, so for kids, because we got asked to do it. So we have a few kids that are signed up, which is awesome. We're doing these boot camps, which get you started. I think all of you guys, I think actually a few of you actually done it, which is awesome. And then we also got asked and we delivered a kids 3D printing birthday party. So there's a lot of changes to how we're doing these training things. Obviously, at the start, I think we were like really targeting businesses, and we still help businesses, right? That's like a big part of our business. But now we're doing a lot more of these courses for kids and like these like kind of lower barrier to entry courses. This design one here is $3.99, but We've got a few spots left for the intake on the 18th of this month, where the live sessions are to learn parametric design. So yeah, we make these on request. So the next one that I'm going to be making is using AI for 3D printing. And you know how I was saying like, oh, I've got this software that I wanted to build. What is it? Index. So I use AI now in like some really cool ways. Arenalo apps. So I made this app using AI. Let's see, I'll drag it in here. I've got to make sure that I don't show you specific user data, which is going to be covered with. Okay, so see this dashboard? Let me take a snipping shot. This will be filled with user data. So I'm just going to do this. I used AI basically to get all of my data from my orders, live data from the websites, and it puts it into a Kanban. These ones are order received, then it's to design, and then it's orders that are printing, and then it's to pack, like in a box. So they sync with my website, and I can see everything in one thing. It took me 20 minutes to make. The next one I want to do is one that helps me design all of my parts. Then also I use ChatGPT to like design certain things and like help me like actually create parts. And you can make 3D models from images, and how do you prompt it? Like I've done all these things with AI that I kind of want to put into a course as well. So the next one I'll make is the AI course. But if you have courses that you want, or if there's not courses, if you have things that you want to learn how to do and you just don't quite know, just start to talk to me about it. I would love to like hear, what it is, because like you guys know, like my goal is to help you guys as much as we can with 3D printing. The selfish thing is we sell printers, we sell filament, right? So that's the idea, is that we create a win-win. And like I need, capital N, need to know what the problems are that you guys have, so I can like better help with them. And that's why I love connecting with you guys here. And yeah, it's also just a lot of fun. I really love these Q&As. It's a highlight of my work week. So yeah, thanks for hanging out again this morning. And yeah, we'll catch you in the next one. See you guys. Take care. Thank you.